Hi, hello, and welcome to this episode of Geographical. Today I'm going to be telling you a quick story about the marvels of modern science and how we can now narrow down the geographic region of where a person may have travelled or lived by conducting an isotope analysis on their skeleton. Today I'm going to be relying heavily on this article by Eric Bartelink and Elsie Chesson on the recent applications of isotope analysis to forensic anthropology, which was published in the National Institute of Health. Isotope analysis has expanded greatly since the 1970s. Its anthropological and archaeological applications can help us to understand human behaviours, such as a person's possible region of birth, where someone lived, recent travel history, gender, health conditions, age at death, and dietary choices. It acts as a so-called black box in churning out geographic data. This can help in narrowing down missing person searches and is a promising area of research for forensic human identification to support long-term Joe and Jane Doe cases. So what are we actually talking about when referring to isotope analysis? And bear with me here as I only got a B in my GCSE in chemistry, but a very basic explanation is an isotope is a type of atom. It is the smallest unit of matter that keeps all of the chemical properties of an element. And as the article tells us, of all the elements in the periodic table, there are only 21 monoisotopic elements, meaning that they have only one naturally occurring isotope form. Isotopes refer to atoms of the same element which have different molecular weights. A typical carbon atom, for example, is composed of 6 protons, 6 electrons and 6 neutrons. It's called carbon-12 or 12C, referring to the sum of protons and neutrons. Add a neutron and you get 13C. It's still carbon but slightly heavier. Add another and you get 14C. Some isotopes are stable, meaning in the case of 12C and 13C, they don't radioactively decay. 14C, however, is unstable and decays at a predictable rate. Because of this, 14C is useful in determining the age of material and is used in carbon dating. A process called isotopic fracturing can help us to understand the environmental influence of an isotope over time. Take hydrogen and oxygen as an example. As they move through the global water cycle, they have different compositions, whether they've been measured as precipitation or compared to tap water. There is a strong correlation between the composition of water and atmospheric temperature, elevation and distance from the coast. Water further inland, in cooler climates, for example, would more likely have a makeup of 1 H and 16 O's, whereas you're more likely to find 2 H's and 18 O's at a higher temperature, altitudes and latitudes, for example. There are a few different techniques of isotope analysis, but one recent new methodology of isotope analysis has been introduced, which involves isotope infrared spectroscopy. This technique looks at how light is absorbed at different rates and can tell us information about the absorption of gases found in our atmosphere. Most research and analysis has focused on 5 main isotopes, which are the main bioelements that have made up most tissues in living organisms. There are hydrogen and oxygen, which can tell us about what we have drank, and because H and O values of water do vary so greatly by geographic region, this can help us to make predictions about the regions and climate a person has been in recently. Each of us are little tape recorders, says Leslie Chesson, University of Utah graduate and president of Isoforensics. It is all about the environment or conditions under which a material has been grown or made. Everything that is happening to a material as it's being composed imprints a little bit of variation on the isotopes. Chesson says that where law enforcement needs to distinguish between materials that appear identical is a strength of isotope analysis. If you look at a drug like cocaine, chemically, cocaine is cocaine, she says. It has the same amount of C, H, N, and O atoms in it. How can you tell a particular shipment batch from another? If it's chemically identical, that's where isotopes come in. Carbon, nitrogen and sulfur are often referred to as the dietary elements and can provide us information on the foods consumed by an individual and give clues on their local geography. Carbon isotopes can vary based on how the plant has photosynthesized, which can help us to understand if a person has consumed plant material directly or through that of an animal, such as a cow. Sulfur can tell us about the proximity to marine influences, such as the consumption of marine source foods or the cultivation of land near a coastline, which is impacted by atmospheric changes across the coastline. Different body parts can tell us about different bits of information. Childhood diet and location of residence can be found by analysing teeth, for example. Diet and location for the last 20 years can be found by measuring bone tissue, and more recent travel history and residence patterns can be found by measuring hair and nails. In modern-day unidentified remains cases, the keratin from hair and nails can be well preserved and thus can be useful from an investigative forensic standpoint, as it can be used to understand movements and activities and diet just before the death, for example. Hair, for example, grows on average 0.4 millimeters per day, and fingernails 2 to 3 millimeters per month. These rates of growth fluctuate as the subject has been sedentary or if it has travelled recently. Therefore, it is useful to measure the difference in isotope composition to understand chronology. Bone tissue can be a useful indicator as it is constantly changing throughout a person's life. It remodels faster in young adults versus the elderly, for example, and is made up largely of collagen, which can be an indicator of the prevalence of protein in a diet. Different bones remodel at different rates, and so a rib bone might give you clues about the geography and diet from the last 5 to 10 years, whereas a femur could tell you information as far back as 25 years. In 2010, a skull was found in the desert of Southern California. Biological profiling identified this as the remains of a young Hispanic woman. Armed with a DNA profile, law enforcement was hoping to be able to identify the woman, but with no such luck. Investigators submitted the bones for isotope analysis, hoping to find if the woman was from Latin America or US-born Hispanic, and if her hair samples could provide any insight into the movements prior to passing away. Carbon data from the bone and tooth enamel suggested that a diet was more consistent with a US-born individual. An analysis of the oxygen in her hair provided an insight into where the woman might have been getting her drinking water between 13 and 3 months prior to her death. The results indicated differences in isoscapes in regions 1 and 2, suggesting a shift in residence towards a warmer region in the last 3 months of her life. To conclude, isotope analysis has been long used to identify chemical compounds found in drugs, explosives, plants and plastics, and therefore it can be useful in forensic profiling. However, at the current time, the ability for evidence to stand up in court is limited. More work needs to be done to develop reference data to support the interpretation and evaluation of isotopes found in human tissue and to create predictive models to support forensic practitioners in their analysis. Either way, it's incredibly useful and interesting, and an exciting field in forensic anthropology, helping law enforcement and historians alike to understand the imprint of a person's environment. And that's it for today's episode. I really hope you enjoyed it. Please like if you liked it, give us a comment on your thoughts, and subscribe for more as I bring out new episodes every Tuesday. All right, goodbye.